This video is the Law of Cosines, and your learning target is I can model and solve problems using Law of Cosines. Okay, so I'm gonna circle the angles so that you can see them. Notice that they are capital letters, and then the sides across from them are lowercase letters. So that's going to be very important in just a minute. So the Law of Cosines can be used to find side and angle measures given two sides and the included angle, or three sides. So that's that stuff from Math 2, side, angle, side, and SSS, side, side, side. So I'm going to write out the Law of Cosines. It'll look like there's three different laws. It's not really. It's just if you're trying to find three different side lengths. Okay, so here are the three different setups that you can have, and I've color-coded it for you. So notice it looks an awful lot like the Pythagorean theorem. Remember that you can only use Pythagorean theorem with 90-degree triangles. So what the Law of Cosines allows you to do is to find missing side lengths, or you can find missing angle measures with any type of triangle. So it's a squared plus b squared plus c, a squared equals b squared plus c squared, but minus 2 times b times c times the cosine of a. So it gets a little confusing. It's a big long formula. But as long as you can identify the different pieces, then really you're okay. So, for instance, if you look at just the first one right here, when it's talking about a, the lowercase a, that's my orange side length. And notice that I'm using the cosine of the angle across from it. So that's what all of these are doing. Okay, so let's look at some examples. So for number 1, we're going to find each side length. And we're going to make sure we round our answers to the nearest tenth, so just to 1 decimal place. Okay, so for number 1, I'm trying to find that side length x. And notice that I'm going to be using the angle directly across from x. So here's what the Law of Cosine says. So the side length I'm looking at, squared, equals the other two side lengths squared, minus 2 times the other side lengths times the cosine of the angle across from the side. Alright, so you can switch the 16 and 28's positions, it doesn't matter. But if you're looking for x, then you have to use the cosine of 121 because that's the angle that's directly across from it. So now, all I have to do is put all of this in my calculator, and I'm going to round to 1 decimal place. And you can do it, you can write it all at one time. I would put like this part in parentheses just in case your calculator gave you an incorrect answer. So here's what you should get. X is actually equal to 39.7. Okay, so now look at the second one. We're going to do it the same way. I'm looking at this side length x, and I'm referring to the angle across from it. So the Law of Cosine says I can do x squared, and it should equal the other two side lengths squared, minus 2 times the side lengths again, times the cosine of the angle across from it. So cosine 36. So all you have to do is put all of that in your calculator, and then make sure you do take the square root of both sides. I forgot to say that the first time. And you should get 16.8. Okay, so it's just like a really confusing Pythagorean theorem, and you just have that extra part because you're trying to account for the fact that it's not a 90-degree triangle. Okay, so notice number 3, you're not given a picture to look at, but that's okay because you have the ability to draw a picture. So I want you to pause the video and I want you to try and draw the picture given the information that you have. So try that in 1, 2, 3. Okay, so your picture should look similar to this. You could have rearranged it a little bit differently. We are trying to find x, and the angle across from x is the 88 degrees. So my Law of Cosine says x squared must equal the other two sides squared, because that's Pythagorean theorem, but then subtract 2 times the other two sides times the cosine of the angle across from what you're trying to find. And then make sure that when you do this, notice that it gives you x squared, and you take the square root of both sides. So x should equal 24.5. Okay, so these aren't too bad so far. So now let's make it a little more complicated, because that's what math does always. So this time we're going to find angles. So when we're finding angles, it's just a little bit more difficult, but it works the same way. So notice in number 4, I'm trying to find the angle measure of x, and my side length across from it is 10. So when I set it up, it should be 10 squared equals the other two sides squared minus 2 times the other two sides times the cosine of x. So what we're going to try to do is we're going to try to isolate that cosine of x. Okay, so everything is just a number. I'm just going to go ahead and get, sorry, that's supposed to be a squared right there. I'm going to go ahead and just simplify everything. Okay, so here's what I've done. 10 squared is 100 equals, I went ahead and I added these two together to get that 190, and then I just multiplied all that together to get the 286. So that's where all this is coming from. So the next thing I'm going to do is I'm going to subtract 290 to the other side. And when I do that, I get negative 190 equals negative 286 times the cosine of x. Just because I'm out of room, I'm going to move down here. Now I'm going to divide both sides by negative 280. So I get 0.6643 equals the cosine of x. So remember back from Math 2 and Math 3, if I ever want to find an angle measure, I'm going to use the inverted cosine function. So when I type that in my calculator, I get 48.4. So just a little more steps involved, but it's easy math stuff that you should already know from previous math courses. The only new thing is the formula and then just plugging it in correctly. Okay, so now we're going to do number 5 together. So for number 5, I'm trying to find x, and notice that the side length across from x is 17. So when I set this up, I'm going to do 17 squared equals the other two sides squared minus 2 times the other two sides times the cosine of x. So what I'm going to do now is I'm going to go ahead and simplify all the numbers. Alright, so 17 squared is 289. 30 squared plus 18 squared is 1,224. And 2 times 30 times 18 is 1,080. And then you have the cosine x. So now I'm just going to start moving stuff over. So I'm going to subtract the 1,224 from both sides. Okay, negative 935 equals negative 1080 cosine x. I'm going to divide both sides by 1080. So I get 0.8657 equals the cosine of x. Remember, if I want to find an angle measure, that's when I do the inverted cosine. And when I put that in my calculator, I get x equals 30 degrees. Alright. So for number 6, you're not given a picture, but you have the ability to draw a picture. So I want you to pause the video and draw the picture in 1, 2, 3. Okay, so now I want you to go ahead and write the equation using the law of cosines. See if you can do that. Try that in 1, 2, 3. And now if you'll just simplify, so get all the numbers together. Okay, and now we're just going to start trying to isolate x. So if you'll subtract 117 from both sides, and then divide both sides by negative 108. And then because you're trying to find an angle, you're going to use the inverted cosine. And then you're just going to type that in your calculator. So you should get 137 degrees. Okay, so now let's do everybody's favorite word problems. Yay! Okay, so in order to do these, you have to understand where north, south, east, and west are. So if you don't know that by now, north, east, south, west. So some people say never eat salty wheat, and then some people say never eat salty waffles, and whoever your elementary school teacher is how you know how to do that. So look at this little diagram, and then we'll start writing. So 2 ships leave a port at 8 a.m. Ship A sails with a bearing of north 68 degrees east at a speed of 17 miles an hour. So let's do it like this. So if I were directly right here, so north and then east would be kind of diagonal. So here's ship A, and we know that he has done an angle of 68 degrees. And then ship B sails with a bearing of south 35 degrees east at a speed of 12. So notice southeast would look like this direction. And we know that this is an angle of 35 degrees. If the ships maintain their paths, how far apart are they at 2 p.m.? And then if you don't know what a bearing is, a bearing measures the acute angle that a path or a line of sight makes with a fixed north-south line. So that's exactly what we have drawn in our diagram. Also, remember that if I look at this, all 3 of these angles have to add to give me 180. So 180 minus 68 minus 35 gives me an angle of 77 degrees. So this is important because when I make a triangle, now I know that that angle is 77 degrees. Let's see, other things we know, we're trying to find this, the distance apart. And then, in order to find the distance that they went, so remember they left at 8 a.m. and we're trying to figure out where they are at 2 p.m. So that is 6 hours. If ship A is going 17 miles an hour, I can figure out the distance. And ship B was doing 12 miles an hour, I can figure out that distance. So if I do 17 times 6, I can figure out that this ship has went 102 miles. And when I do 12 times 6, I get 72 miles. So now I have the side lengths. Okay, so if you need to redraw the picture, you can. So this is 77 degrees. This side is 102. This side is 72. And X is what I'm trying to find. So now I can set it up like we have the previous problem. So X squared has to equal 102 squared plus 72 squared minus 2 times 102 times 72 times the cosine of 77. So the nice thing about this problem is all you have to do is type all of that in your calculator. When you do that, you should get approximately this. And then make sure that you are taking the square root of both sides, just like when you do the Pythagorean theorem. So my answer is 110.8 miles. All right. Okay, so for these two, I want you to try to see if you can draw the picture. So let's just focus on number 8 first. I want you to read it, look back at that problem we just did, look at the compass that we wrote, see if you can figure out how to draw the picture, and then we'll talk about how we actually are going to solve this. I'm just kidding. I think we're going to skip this just because I'm not going to worry about this in Math 4 because you have to convert the coordinates to degrees and okay, don't tell anybody, I just don't see the purpose in it. So let's just focus on number 9. This is our last one. I think 7 and 9 are good for Math 4, but I'm going to skip problems like number 8 just because I hate them. Okay, so a helicopter spots 2 landing pads below. The straight line distance from the helicopter to the pads is 14 miles to landing pad A and 8 miles to landing pad B. If the landing pads are 20 miles apart, find the angle of depression from the helicopter to landing pad B. So, I know that's overwhelming, so what I want you to do is I want you to pause the video and I want you to see if you can draw a picture of the situation. So, try that in 1, 2, 3. Okay, so something like this. So, I just labeled this top little part, that's your helicopter. 14 miles to A, which is how I get 14 on that left side. 8 miles to B, which is how I get 8 on the right side. 20 miles from A to B, and we're finding the angle of depression from the helicopter to landing pad B. So that's how I got X down here. That looks a little weird. That's supposed to be X degrees. Okay, so now I want you to write how you would set up the law of cosines. So try that in 1, 2, 3. Okay, so it should look like this. And now go ahead and simplify the numbers. So go ahead and isolate X as much as possible. Alright, so you should get it down to this. We're going to use inverted cosine because, once again, we're trying to find an angle. So my answer is going to end up being 33.1 degrees. Alright, so skip any that have weird coordinate systems where you would actually have to convert them, because we're not going to worry about that. That's more pre-cal stuff. If you're going to take pre-cal, I'm not sure why you're in Math 4, but if you are, then you can come to me separately and I can show you how to do this if you just really want to learn. If you have any questions, let me know.